Hello everyone and welcome to the first of many C++ video training modules brought to you by 3D Buzz. My name is Jason Busby, also known as Buzz. And over here we've got Mr. Joel Van Enwick, known as Bingo. How's it going, Joel?
Really good. How about you?
Not bad at all. Been looking forward to getting into some C++ programming videos for quite some time now. Now, for everybody out there, let me go ahead and let you know, to help keep the load balanced over here at 3D Buzz, Joel will be the mastermind behind these video training modules. So his email address is joel@3dbuzz.com. You're going to get tons of email. Everybody already knows mine. So anyways, if you get stuck or have any sort of problem, feel free to go ahead and give Joel an old email. He'll be glad to help you out. But seriously, though, what we're going to be doing is taking a look at how we can go about developing applications. And this is the first of a course, training videos for a course that's going to split off into two different tracks after we get everybody up and comfortable with working with C++. And these two different tracks are, one is the Maya Technical Direction, which is going to be working with the Maya API for developing plugins for Maya to extend Maya's functionality, which is really cool stuff. And then the other direction is going to be game design, as we see this becoming more and more popular, and it's becoming more and more, let's just say, involved in developing an actual game engine. We thought it'd be really cool if we just took it upon ourselves to show you guys how you could do it yourself with a complete set of videos and online class support that walks you through the entire process of developing a game engine. Now let's go ahead and start ultra simple, Joel, just for a minute. What is C++?
C++ is just a programming language that we use for a lot of different tasks these days.
That's right, and it's compilable, correct?
Yes, it is.
What does compilable mean?
Basically, compilable means after you can take your source code and you compile it into a executable, something that you can run after it's created.
So basically what we do is we take it down to machine language.
Right.
Okay, so it doesn't need to be interpreted like...
It's not an interpreted language like, say, Java.
Java. Or let's say for those that are going through the MEL class, because we've got a lot of member sponsors going through the MEL TD side right now.
Right.
And that is an interpreted language. It's handled by Maya itself.
Right.
And that's where things kind of get a little slow when you deal with interpreted languages, right?
Right.
As opposed to a program that you develop that the machine can directly understand without any sort of assistance.
Right.
The interpretation stuff. All right, well, that's pretty cool. All right, well, what about those out there that are watching this video right now saying, I'm looking at Microsoft's development environment right there. I'm looking at Visual Studio. What's up with that? I've got Linux. Am I hosed?
Well, not really, because basically the concepts that we're going to be giving can be applied to any compiler that you may use. So GCC, DJGPP, anything that you use can be applied as well. And
those, and you can get a lot of different compilers that are free as well, right? Now this is Microsoft Visual Studio.net. This is 2003. It's the standard version. It cost me like $99. I just went out to CompUSA and picked it up so that we could record these videos for you guys. But again, if you don't have this, you don't have the money, no problem. You know, you can write your C++ stuff inside of a text editor for your life.
Right, and there's a lot of free IDEs out there.
Exactly. So I mean, if you're set, don't let it, panic you. Now we will be doing some stuff that's going to end up being Windows specific a little bit later on. And in regards to the Linux users, there will be, let's just say, different workflows, different workarounds, et cetera, et cetera. And we'll point these things out when we start getting to them. And Joel, I think we should go ahead and let them in on one more little secret. With these videos, I get to play the student.
Yes, you do.
What I'm trying to do, and this is going to be tough, is think from a beginner's point of view and make sure that I just continuously harass Joel for information so that he makes sure that concepts are nice and clear. I feel that's better than me just sitting over here acting as a commentator along with Joel. That way, questions are thrown around in classrooms all the time, so why not have some questions taking place here?
Right.
Okay, so with that, in this particular introduction video, we're going to go through the process of writing a complete C++ program, compiling it, and executing it. So, Joel, let me go ahead and hand it over to you.
All right, so basically what we have here is the IDE, as we talked about before. And right here we have our start page, and this is where we're going to be creating our new projects or whatever. You can access pretty much everything you have here up in the File menu. Down over here to the right, we have our Solution Explorer, and this is where we'll be actually navigating through our source code, our header files, our source code, our resources, anything we may have. We can also change it over to a class view, but we'll see that later. And down here we have our dynamic help, which is extremely helpful.
Very helpful.
Right. And down the bottom here, this is where A lot of information is pumped out by our compiler, our linker. If we have any errors, it'll be shown down here, and all sorts of other kind of information will be displayed down here.
And Joel's mentioning things like compiler and linker, and for those of you out there that are completely new to programming in general, don't let that scare you, the fact that he's talking in some type of geek talk. It's all good. All that stuff will become nice and clear before this lesson is over.
Right.
And the project thing, let me go ahead and bring your attention back up to the whole start page. This area is really cool when you start working with multiple projects, being able to see when they were last modified, a list of them quickly, etc., etc.
Right.
I just wanted to add that. Okay, Joel, so what do we need to do to make a program?
So we can go ahead and press New Project, or we can go to File, New, and then actually create a project.
Okay.
So let's go ahead and do that. And you'll notice we have Visual C++ projects, and inside of our templates folder right here, these are all sorts of different templates that can be created. So we can create a Win32 console project, an actual Win32 project with Windows and everything, and all sorts of just different things that we can create.
And this makes me think of another very beginner-type question that you may find from a student that's never taken any programming before. Well, I understand that C++ is a programming language, but what can you use it for?
Well, pretty much anything. So, I mean, you can create drivers, you can create actual Windows applications. I mean, the list just goes on and on and on.
So do I see programs that have been written in C++ often when I run Windows?
Oh, yes,
Like
constantly.
Most everything I see?
Pretty much.
One
There's
way
a
or
lot.
the other? Yeah, absolutely. So that's, again, very basic stuff, but something to understand that, well, what's C++ written for? Well, get on your computer and just start running programs, and most of what you see is, most of the time, C++ was used. And I hate to keep hitting the beginner stuff, but this isn't just the introduction. I've heard of this language called C, and now we're looking at C++. What's the key difference there?
Well, there's a lot of differences inside of C from C++, but it's kind of... Actually, there's a lot of differences, okay? So we have, say, classes in C++.
Can I add something there where I can suddenly get intelligent for just a minute?
You can do that.
Thank you. All right, the biggest thing is the fact that C++ is truly object-oriented.
Completely object-oriented.
And that is, actually, it's a really big deal. It's a different style of programming that once you get comfortable with working with it, it is just absolutely awesome. Where basically you go and you define a series of classes, and these classes are templates for objects. And these objects have functionality and various parameters that can be set about them, all sorts of different things. And you can also publicize parts of it, and you can keep certain parts of it private as well, so that you can protect data that ends up getting into an object that's being worked on. And once you set up an object-oriented programming and you get comfortable with working with this style, it's tough to go back.
Oh, yes.
Because it is such a nice way of working, because in the real world, the way we deal with everything, it's all objects. Joel right now is an object, and he's got functionality built in with him, and he does come from a class, a template, the template of human. Actually, that's the highest class, because you can derive from that the template of male, and then from that we spit out a Joel object by accident. And we can't really do that with C++. I mean, you can do some simulation type stuff that's kind of similar in a way.
Right.
But you know, true object orientation, when you start getting into encapsulation and polymorphism, and there's a lot of cool stuff that you can do with C++ that just can't be done with C. But as I say, in Joel, the object derived from the class human male, if I kick Joel right now, his functionality is going to have him get mad and probably kick me back or run screaming. It all depends on what's going to happen internally.
Probably kick you.
Yeah, that's kind of what I felt. But Joel knows to eat. He knows to do all sorts of stuff. So the direction we're going, C and C++ are very similar in basic syntax.
Right.
But when we start getting over into the whole object-oriented world, that's where C++ just takes off.
Right.
And C just kind of stands there and waves bye-bye to it. And, of course, we want to teach you guys the coolest, the greatest, the newest that we can. So, of course, we're going to be looking at C++, and we will be getting into all this object-oriented programming in depth. And Joel, not me, I'm just a student. And
Sure you are.
This little spurt was an accident. but Joel will make sure it's just as clear as it possibly can be clear. And if it's not, I'll just ask him more questions. Wow, I just had this flash. What happened? What were you talking about, Joel? I'm no longer intelligent. I'm now a student again.
So what we were talking about is templates, and what we can do is go down here, and we can create a Win32 console project.
Well, what's Win32?
Win32 is basically Windows application. So it has a window, it can have menus, etc.
Okay. So a console. You did that to me yesterday. A console application or a console project. It's going to have windows with menus and everything?
Well, not in this case. With a console project, it's not going to actually have any menus or anything. It's going to be a simple black screen.
Kind of think DOS, though
Kinda
it's not
DOS-ish, but not really DOS.
It's not really DOS. But I'm running Linux.
Well, then in this case, it's going to be different. However, the code that we're going to be creating, the actual source, can be run on any compiler, and it will still be compiled and run efficiently.
Fantastic.
And
Okay.
So let's go ahead and down here by name, we can go ahead and create this and call this Hello World, because it would just be wrong if we didn't create a Hello World project.
Exactly. Go to the bookstore, pick up any book on how to program, I don't care what language it is, and you'll find Hello World at the beginning.
It's a necessity.
It is.
So under location, you'll notice that this is where all our projects are going to be placed. And if we have create directory for solution selected, then it's going to automatically create a directory inside of our project folder called Hello World, and then inside of that folder we're going to be putting all of our source files, header files, etc.
Excellent.
So let's go ahead and press OK, and we'll get this wizard dialog here. And if we go down, this is just a simple overview. If we go to application settings, we'll get all these cool settings. What we want is to create an empty project so that we can start out with a clean slate and show you exactly how everything is done.
So, Joel, my guess would be it's pretty cool having this application wizard at the very beginning, just for the simple fact that as we start getting into more complex programs and we start utilizing Windows, etc.,
right,
it's pretty nice having the application wizard go in there and lay down a foundation for you to start from, as there's a lot of overhead that's sometimes involved with Windows
when we work
and
with Maya API, etc., it's a lot easier.
Exactly.
So let's go ahead and press Finish. And you'll notice that if you look in our Solution Explorer, no files are actually created. We have source files, header files, resource files. These are folders.
Okay.
But there's nothing inside of them.
Interesting.
So to start out, what we need to do is select our folder, right-click, and under Add, we could also go, of course, into here and actually add an existing or new item here. But what I usually do is just right-click, press Add, and we'll add a new item. And we'll get this kind of dialog like we did before.
Wow, a whole other list of things to choose from.
Exactly. And you'll notice we can create a CPP file, which is our source file, and we have header files, etc., just a huge list of things that we can create.
But the big thing that we are going to focus on is going to be the C++ or the .cpp file type.
Right. So let's just give this a name. We'll call this Hello World as well. This is going to be our main source file. So we'll press Open, and now that's created a new Hello World.cpp file.
Cool.
So now we can start typing our source code.
All right.
So let's first type in include, which is a preprocessor directive, which in other words that means this is not actually compiled. This is something that is sent to the compiler to give it specific directions to do something.
Okay.
So in this case it's included with a pound sign, because it's always included with a pound sign to send messages to the compiler.
Okay.
So in this case, we're going to say include the file IOStream. So what the compiler is going to do is take that information and say, okay, I'm going to include IOStream into the final executable that we create.
Exactly. Now let me add a little bit to that as a student, I guess. Really important thing here, starting out with a blank application that we're designing like this, or a blank program. If we did not use the include here, we would have to write
a
lot, and I do mean a lot of stuff, right?
Right.
Okie dokie.
So let's go ahead and, let's go ahead and create our main. Actually, let's not include, just type main and 2 parentheses. This is declaring our function, our main function. And we can end that with 2 curly braces, left braces and right braces.
Mm-hmm.
Curly braces.
Oh, yeah. I just always call them curly braces.
And so this is our main function. When the compiler, the linker is actually going to be looking for our main function. Okay. So that when we run the program, when we actually compile it, it's looking for this main function. So this can be anywhere. I mean, there can be 30,000 functions before main, 30,000 functions after. It's still going to be looking for main and run that first.
Okay.
So inside of our main function, what we want to do is just output a simple message saying hello world. So what we can do is type std and : which is our scope operator, and we can type cout, which is our output stream. And we can say our output operator here, and we can just say, in quotation marks, hello world, exclamation mark, end it with quotation marks, and then we'll add an end L at the end, which means add a new line.
Okay.
So we'll explain all this in just a second. We can go up into build, and we can say build solution, or just press Control-Shift-B, and what this is going to do is actually build it and link it. Okay. So if you notice down here, we have a little bit of a problem. NL undeclared identifier. What we can do to change that is say std : and Shift B again, and everything works fine. The reason for this, well, actually, I'll explain that in just a second. Let's make sure this works first. So we can press Control F5, and it actually runs our application. And you'll notice we get our console here, and we'll have it say, Hello World, end line, and press any key to continue. Okay. So it works. This is our simple application.
Okay. As a beginner, I would say, I didn't see anything simple about what you just did.
All right, well...
Here we go.
Basically, what we have here, there's a lot of different ways to do this, but what we're doing is saying STD, that's basically a namespace, okay? So what a namespace really is it provides an additional level of scoping that can help you organize your code and guard against like name conflicts, etc. So by saying STD holds a group of names and a group of functions that we can call, and it will run certain operators. Like in this case, STD cout. Cout is our function, and what its job is a stream, and it can output text to our console.
Okay.
So the scope operator here is saying cout is going to be what's on the right of the scope operator is inside what's on the left, which is our namespace.
Okay.
So it's inside of it. So that's what our scope operator is doing. It's saying namespace cout is inside of our STD namespace.
Okay.
So what we're going to do is output hello world to that stream, cout.
Cool. Now, unfortunately, we need to really talk about something else, too, because someone who's watching this who has not gone through any of the Maya TD stuff may be saying, well, what's a function?
Right. Well, a function is basically something that you can call. So we can have a function that just adds two numbers together.
Okay.
We can have a function that does pretty much anything, and all we need to do is call that function.
And then right here we're looking at where we've defined a function, correct?
Right, we have. Okay. And all the basic syntax is we have a lesson on functions, but just a simple overview is we have our name, and then inside of our parentheses, you have to have parentheses. You can place different arguments that you can pass to your functions,
and we'll get to the arguments a little bit later.
So, and then to define the
body of
the function, what you need is two curly braces, a left and a right. Okay. So the left start, right end.
Okay. Now, right now we're just giving you pieces of this.
Right.
And let me say this. For someone who's never, ever worked with programming at all before, I understand the way you feel right now. You're looking at what Joel just put up there, and it is the most cryptic stuff you've ever seen in your life. And Joel, while he is explaining what it means, it sounds completely cryptic, even in the language he explains it to you in. Let me say this.
It's Greek.
Yes. Greek or geek. It's all the same. What's going to happen is things are going to start becoming more and more clear. This is where I just chime in for just a second as Buzz, myself, and say just relax. As we start digging deeper and deeper into this, things will begin to become more and more clear. So I understand right now that for some of you that are completely new, this is going to look very intimidating.
Right.
But I'm just saying, hang in there with these lessons. You'll see that it'll suddenly start to become more and more clear. Okay. Now, another thing, Joel, I think right now before we move any further is you've already talked about building, you've mentioned compiling, and you've mentioned linking. This might be a good area to go ahead and put a little additional meat onto that skeletal thing that you just mentioned in regards to what exactly is happening when you compile and link and what's going on.
Well, basically what it's doing is if we go up into our tools here, you'll notice that build, you'll notice we have a compile here. And what compile is doing is basically taking all the source that we have right here and compiling that into machine language.
Okay.
And then what the linker is doing is taking the source that we've just created and taking any files that we may have included, say our include IOStream here. The linker is going to say, okay, I need to take IOStream and I need to take the actual assembly, the source file, the machine language that I've just compiled, and link those two together. So I'll take the IOStream and take what I've just compiled together and link it into a final executable.
Cool.
So let's go ahead and continue?
Yeah, absolutely.
All right. So basically we have our hello world here, and as you can see we have our output operator basically, and it's outputting hello world to this cout stream.
Mm-hmm.
And then we output another thing that's also inside of standard, remember. Mm-hmm. The function is endl, the name,
mm-hmm.
and this endl is basically an end of line.
Right.
We could, of course, erase this just to give another look. Actually, to make it a little bit easier, let's just Control-C this,
mm-hmm.
copy it, and paste it down here. And this brings up another thing, and that's comments. Comments are actually very similar if you've used Mel before. You can use the two forward slashes.
Mm-hmm.
And what that does is comment it out, and you'll notice anything that's commented will turn green.
And
so
that's
very cool.
Single-line
comment. That's a single-line comment. If you want to do a multi-line comment, what you can do is say forward slash, and then the asterisk. That's the beginning of a comment. And if you want to end the comment off, you need to do a
asterisk,
thank you,
slash.
and /, and that sections off that whole area and makes that whole area a comment.
Just be careful if you start trying to do like embedded multi-line comments and all.
Right. That could be a little bit confusing.
Yes.
So let's erase that out, and we can just comment this one piece out, and I can show you another way. Instead of using endl, we can delete all of this out, and instead we can put a /n, which means a new line.
Right. It's a special
character. Escape character.
There
right.
you go.
So if we compile this again, so we can just press Control F5 and it'll say, do you want to build these? We can say yes, and then it builds it and runs it. But you'll notice something very, very interesting. I actually used the wrong one. So let's press space on this guy, and let's go into here, and let's change this over to the other backslash.
Yeah, it's called a backslash.
And if you see that, phew, there's our hello world with the end of character there. My brain kind of just stopped for a second there.
For a second, I was like, wow, he's about to show something I didn't know. Cool.
Oh, wow. So let's press any key to continue.
But we will start talking about escape characters and escape sequences a little bit later on when we start getting into working with strings and all.
Right. So basically we have that. And there's another thing that we might as well go ahead and show in our beginning lesson here. And that's we have this std cout. And that can become a little bit frustrating if you use it overly much. If I wanted to say, okay, std cout, and I have to type all of this out and say, Joel, I'm here, or something, just something random.
Right.
And then you have to type out std : cout every single time. Well, to make that a little bit more convenient, what we can do is go up to here before our main function. We can just press enter here and say using namespace std. So remember, we set std, which is our standard library, is a namespace. And by saying using namespace std, it's recognizing every single name that's defined inside our namespace std.
Excellent.
So what we can do is go down here, and now if we remove this std and Control F5 to run it, it automatically builds it, and it runs fine. No linking errors.
Right. Very cool.
So that's something very convenient. However, sometimes you may not want to include every single namespace. So what instead you could do is let's actually comment this out so that people can still see it.
Okay.
And we can say using std cout. So now it's recognizing standard library : cout. So all we need to do now is just say, as we did down here, with cout. Then it recognizes that name. So if we press Control F5 and run this, you'll notice that everything is still fine.
Very cool. Another thing I'll go ahead and point out, just again from an introductory point of view, is the fact that Joel's using semicolons.
Yes, I am. That's very, very necessary. Every single line after every single statement needs to be ended with a semicolon. So, very important.
And we'll be, again, talking about that a little bit later. Right now, remember, this is just an introduction.
Just to get you started.
This is a taste. That's all it is. Not something meant to scare you, which I'm sure it is, but just a taste.
Right. So another thing we also may want to throw in here, which we're going to be seeing throughout this thing, is that C++ is a free format language. In other words, we can place spaces anywhere we want.
Okay.
We can put a million enters here. We can type tab. We can type cout. It works, and that still works. If we Control F5 and play that, well, actually, no, it did not work. You'll notice that we do not have endl.
That's
so
right.
That's actually
we only
an important
specified
thing.
cout.
So what we need to go up here and type using, and what is it, Buzz?
I don't know, std, and then we put in some cute little colon thingies, and then we go ahead and specify in. Look at you typing all that out. What is going on here?
You're an awesome student.
Thank you.
I can read your mind.
Thank you.
So now if we press that again, and we'll build it, and now it works fine. It works. And as it says here, if we press any key to continue, notice that this white space means absolutely nothing. The compiler takes away all white space and doesn't really care. The only place where white space really makes a difference is inside of our quotation marks here when we're defining a string or something. Otherwise, you can put white space wherever you want, and please do so. Make your code clear. Make it nice looking. Put white space everywhere.
Formatting is so important.
Right, it very much is. So actually with that, that's actually going to wrap up this lesson.
Okay, let me go ahead and put this here at the end. Again, the idea is just to give you a quick look at the environment in which we're going to be working, which is going to be inside of visualstudio.net. And don't panic. I know right now we just went through a bunch of stuff that seemed kind of scary. I've already said this a couple of times, but this is very important for those that are completely new to this. It will become more and more clear. Practice along. Try this beginner intro lesson out. Get a feel for it. It's all good.
Yes, okay? It is.
So with that, let's go ahead and wrap this lesson up. Thanks, everyone.